Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we were solving the questions of GATE 1992. We have completed 1990 and 1991, and we have started 1992 from section B. I just want to inform that because I am at my home, so it is difficult for me to solve questions on laptop and upload solutions. One, I'll get back to my room, then I'll upload all the solution as soon as possible. And don't worry, I will upload all the solutions till end of the November. So today we have new question and we will solve this. We will solve this question. This question is energy balance along with the sociometry. So this is from process calculation part. One question of energy balance we will face in the GATE exam from non-isothermal reactors from chemical reaction engineering subject, and one kind of questions like this. This comes under the process calculation, which is energy balance with sociometry. So without wasting time, we will go into the question. The question is saying dry methane is burned with dry air, both at 25 degrees Celsius initially. The flame temperature is 1300 degrees Celsius. If complete combustion is assumed, how much excess air is being used? The reaction is CH4 plus 2O2, that gives CO2 plus 2H2O. Standard heat of reaction. We have given with the standard heat of reaction this, okay, and molar specific heat of the gases. Molar specific heat, that means joule per mole Kelvin. In some cases, it is joule per kg Kelvin also. So, very first thing I want to tell you that the reactant is at 25 degrees Celsius and the product is at 1300 degrees Celsius. Always remember that in the energy balance, any kind of energy balance questions, T reference is there. Reference temperature is always there. And that T reference is also equal to 25 degrees Celsius. Okay, so always remember T reference is also equal to 25 degrees Celsius. So we'll go into the question and it will be clear to you very soon. We have to find the excess air required for complete combustion of methane. Okay, very first thing, for a question of energy balance along with the sociometry. So this is the equation for energy balance along with the sociometry. Heat added to the system plus heat of the reactants is equal to heat of the product plus heat of the reaction. Most of the combination reactions are exothermic reactions, so heat evolved from the reaction and negative sign is for the exothermic reaction. So Q added to the system plus heat of the reactant is equal to the heat of the product plus heat of the reaction. So as I said, so Q added to the system will be equal to the NCP delta T, T minus TR. This T is the temperature at which the reactant or product is at, and T reference, TR is the reference temperature. It is always 25 degrees Celsius, 298 Kelvin in all the energy balance calculation, plus delta H of the reaction plus NCP delta T of the reactant. So we have put it the value of T reference. Q added to the system will be equal to the NCP delta T minus 25 degrees Celsius, that is of product, plus standard heat of the reaction, that is NCP delta T of the reactant. This will be equal to 0 because the reactant is at 25 degrees Celsius and T reference is also 25 degrees Celsius. So this all term will be equal to 0. So we will calculate Q is equal to NCP delta T of product plus standard heat of the reaction. Okay. We have to calculate the N, number of moles of each component, at the product, because reactant side we have 0. For product side we will calculate all the moles of the each component. At the product we have CO2, at the product we have H2O, at the product we have left O2. But CH4 is not there in the product because complete combustion is assumed. Okay, no CH4 is left, no methane is left. So let X mole air fed into the reaction and 1 mole of CH4 reacted. Okay, now O2 in air 0.21x, we know that 21% of oxygen there is in air. N2 in air 0.79 per x. O2 reacted, stoichiometric coefficient of oxygen, stoichiometric coefficient of CH4 into moles of CH4 reacted, that is 2 mole of O2 reacted. O2 unreacted, O2 fed minus O2 reacted, that is O2 unreacted. So O2 fed 0.21x minus 2, that is O2 unreacted. This amount is at product side. This amount is at product side. Now CO2 formed 1 mole, CO2 formed 1 mole because CH4 reacted 1 mole. So stoichiometric coefficient of CO2, stoichiometric coefficient of CH4 into moles of the CH4 reacted. H2O formed, similarly 2 moles. Now solving for heat of the product. Heat of the product, we will solve individually each term. So NCP delta T of CO2, NCP delta T of H2O, NCP delta T of O2, NCP delta of N2. Since N2 is the inert component, whatever the quantity will be at the reactant site will be equal to the quantity at product site, because it does not react with any of the component, right? So CO2 1 mole produced, specific heat capacity we have given, so 1 mole and this joule per mole Kelvin. So mole will cancel out, Kelvin will cancel out. So we have left with only joule. Okay, so this whole term will be in joule. Okay, so similarly for H2O, 2 mole produced, 40.45 is the heat capacity, and this is the del T minus, because 1573 is equal to 1300 plus 273. So 1573 minus 298, because this is the reference temperature for H2O. Similarly for O2, similarly for N2, right? Now for the solving delta heat of the product, we will get this and putting all the value in equation 1. Now this is the main equation we have seen in the starting of the question. So Q added will be equal to this whole term is equal to delta heat heat of the products, summation of the heat of the products. This is the heat of the reaction delta HR, and C the unit of delta R, joule per mole of CH4 reacted. Now I have put it complete value. So 8.028 into 10 to the power 5 moles of CH4 reacted. How much moles are reacted? 1 mole reacted. So this mole and this mole will cancel out. Now Q is 0 because we are not adding any of the heat to the system. Okay, so Q will, in this type of question, energy balance plus stoichiometry, in 95% cases, if it is not mentioned in the question that we are adding heat, the Q will be 0 always. This will be 0. I told you, I have told you why. Mole and mole will cancel out, I told you earlier. So on solving this, we will get X is equal to 17.25 moles. X is what? X is air fed. So percentage X is air fed minus air theoretical required divided by air theoretical required. So air theoretical required 2 mole theoretically reacted, and for air we have to divide 0.21 by 2, so 9.52. So percentage X is air required is this 81.2%. Okay, so hope you have understood this question, and if you have any problem, any doubt, just comment it below. I'll explain you. Okay, and this is straightforward questions, just putting all the values and matching the units, you will get the answer. Okay, now today we will solve a practice question which is on the topic of catalyst deactivation, and this question is important because catalyst deactivation is the new added topic in the GATE since 2-3 years. The GATE is asking about catalyst deactivation. So today we will solve a new question. It is just for a practice question. It is so consider reaction A that gives D and U, where rate constant A gives D is Kd and rate constant A gives U is Ku. The rate of the catalyst decay is first order. This is very important. The rate of the catalyst decay is first order. So for first order reaction, the catalyst decay is given by this. A is equal to A naught e की power minus Kt. Okay, where K is the decay constant. So if you don't have any kind of knowledge about catalyst deactivation in the level spill, I think the chapter 17 is there. There is a small part catalyst deactivation, or it either could be different like 17 or 18. I think it is 17. So just go through that, or if possible, I'll attach my note in the end of the videos for specifically for catalyst deactivation, so that everything will covered from that notes. No need to go into the book. Okay, so this is the decay constant for each reaction. This is decay constant for undesired product. This is decay constant for desired product. D is desired, U is undesired. Always remember, decay constant and reaction constant are two different things. Decay constant and reaction constant are two different things. Is independent of reactant concentration. Okay. The rate of formation of both D and U are first order with respect to the reactant concentration with Kd. This is reaction constant for desired. This is reaction constant for undesired. First order reaction. If it is desired to change the catalyst when the rate of the formation of undesired is half the formation of desired, at what time should the catalyst be changed? Okay. So very first thing, for a first order catalyst decay, activity coefficient is given by this formula. Remember this. For reaction 1, Kd will be replaced by Kdd because Kd of desired. So we will get this. For reaction 2, decay activity, catalyst activity will be given by this. Okay. Now, rate of the reaction is given by rate of the reaction. Rate of formation of D is given by KdCaA1. Rate of formation of D is given by, sorry, this will be U, not D. This will be U, not D. Okay. Rate of formation of U is given by KuCaA2. Put this value of A1 from here and A2 from here. Okay. Now, it is desired to change the kettle when the rate of formation of undesired is half of the formation of desired. So rate of formation of undesired is half of the rate of formation of desired. So we put it all the values. Okay, RD, RU, these are RD and RU, and we put values of A1 and A2. So after this all is mathematics, we will get this. Okay, at the end on solving we will get this, and solving this mathematical equation. And don't forget the unit for a single second. Okay, so we'll get T is equal to 22.35 days. Okay, this is very important question, very good question according to the GATE point of view, because GATE is asked just these type of question when one quantity is half of the other and one quantity is twice of the other. These kind of things GATE always juggled with. Okay, so hope you understand this question, and if you have any problem, any doubt, just comment it below. I'll explain you, and at the end of the video I will upload my notes as well, for specifically for catalyst deactivation, so that you will get an idea. Okay, so bye guys, take care, and take care of your parents also. Bye guys.